Hello everyone, this is Abhishek here, and today we are going to discuss about merge case sorted list. Understanding the problem statement. Imagine you have a several sorted lists, each representing a collection of data in ascending order. The challenge is to merge all these lists into one single sorted list, preserving the order of element. This problem has wide-ranging application from database management and data analysis to scheduling and resource allocation. Input. The input to the problem is an array of case-sorted linked lists. Each linked list contains elements in ascending order. For example, the input might be of array of three lists given below. List 1, 1, 3, 5, 7, list 2, 2, 4, 6, list 3, 0, 8, 9, and the output. The output is a single sorted linked list that contains all the elements from the input list. The elements in the output list must be in ascending order. In the example above, the output could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Approach. Brute force approach. One straightforward approach is the iteratively traverse all the linked list. Insert each element into temporary list and then sort the temporary list. While simple to understand, this method has significant performance drawbacks. Algorithm. The brute force algorithm involves the following steps. Creating a temporary list. Creating a temporary list. Initialize any empty list to store the merged list. Iterate through all linked lists. For each linked list, traverse its nodes and insert each element into temporary list. Sort the temporary list. After all elements are collected, sort the temporary list in ascending order. Approach 2. Divide and conquer. The divide and conquer strategy offers a more efficient way to merge the list. We can recursively divide recursively a problem into smaller subproblems, solve each subproblem, and then combine the solution to arrive the final result. Divide, split an array of k lists into two halves. Conquer, recursively merge the list in each half. Combine, merge the two sorted halves into a single store list. Approach 3. Heap-based approach. The heap-based approach leverages the properties of mini-heap to efficiently merge the sorted list. A mini-heap is a data structure that stores element a way in a way that the smallest element is always at the root. Initialize a mini heap. Create a mini heap and insert the head nodes of all k leads into the heap. Extract the minimum element. Repeatedly extract the minimum element from the heap and add it to the merged list. Add the next element from corresponding list. When an element is extracted from the heap, insert the next element from corresponding list into the heap. Repeat until the heap is empty. Continue extracting the minimum element, adding it to merged list, and inserting the next element from the corresponding list until the heap becomes empty. Implementing the heap-based approach. Implementing the heap-based approach requires using minimum heap data structure. Most programming languages provide built-in libraries, provide built-in or modules heap operation. Time and space complexity analysis. Let us analyze the time and complexity of heap-based approach. Complexity, time complexity, O n log k, where n is total number of elements in all the lists, and k is number of lists. Space complexity, OK, is the heap stores at the most k nodes, one from each list. Handling edge cases. When implementing a solution, it's important to consider edge cases that might arise. Empty lists. Under the case where the input array of lists is empty or contains element list, the output should be an empty list, a single list. If the input contains only a single list, simply return the list as an output. Null pointers. Validate that the nodes in the linked list are not null pointers before accessing their values. Handle null pointers appropriately. Comparison with other approaches. Let's compare the heap-based approach with the brute force and divide and conquer approaches and time complexity and space complexity. Brute force O n log n and space complexity is O n. Divide and conquer time complexity is O n log k and space complexity is O n. Heap based time complexity is O n log k and space complexity is OK. The heap-based approach is generally the most efficient solution as it has the time complexity of O n log k and the space complexity of OK. The brute force approach has the higher time complexity and the divide and conquer approach has the higher space complexity in the worst case. Conclusion and key takeaways. In merge case sorted list problem is a valuable exercise in algorithm thinking and data structure utilization. We explore various approaches, analyze their efficiency, and filter their highlighted the importance of handling edge cases. The heap-based approach offers an optimal balance of time and space complexity, making it a preferred solution for this problem. TKKS. This guide has provided you with a deep understanding of merge case sorted list problem and its solutions. Remember to consider the trade-offs and trade between approaches and choose the most suitable on based on your basic requirements. Thank you.